How do I write the first one? I want to make sure that you guys understand how to say these too. Yes.
You grab the 7 and then you make it a 9 square root.
Okay, so that's why I wanted to make sure that you understand how to say this. Whenever you're talking about the index, you just say the nth root. So the 7th root of 9 to the 4th power. Okay, so try to get that English language down in terms of math. So the 7th root of 9 to the 4th power. But what is 9 to the 4th power? You can check your calculator if you do not know. Perfect, done. Okay, how do this one's a little tricky because you got to make sure that those parentheses stick with you. How do you write this or say this?
7 square root is 6,500 square root.
Oh, no, I mean the next one. Sorry, my bad. Number 2. Say it with your words. 3x in parentheses. Thank you, the 5th root. And then the 4 goes here. Okay? You need to be able, I know that it's kind of hard, we're used to saying square root. But you need to get used to, because when I'm teaching you, or Ms. Marquez is teaching you, if we say the 5th root, we want you to know what we're saying. So make sure you understand that's the 5th root of 3x to the 4th power. Okay, going this way, I'm going to just write these out. Hopefully you did okay. I feel like this way is pretty straightforward. Now, number 4, though. Yeah, it would be the same of 2 in a way. So I would have 7x cubed. However, it's all square rooted. Some of you probably just put the square root with the x. Okay, but the 7 is also being square rooted as well. And if you don't represent that, then it's a completely different expression. Okay, if you would have just put this, that's wrong because technically you're just saying 7 times x to the 3/2 power. But 7 has a square root too. That's why you can't have that. Questions? Why are you confuzzled? You think you're good? Okay. Because remember when we distribute this in, you'd have 7 to the 1/2, which is valid because it's under the radical. If it wasn't under the radical, it shouldn't have a power with a fraction. Okay? So let's talk about these perfect 15 square root or squares. What's the first one?
1.
Second?
4.
Third?
9.
Fourth?
15.
Fifth?
25.
Sixth?
36.
7?
49.
8? 9?
81.
10?
100.
11?
121.
12?
144.
13? 14? 15. Very good. Okay, no, you do not have to memorize all of these. However, it would absolutely benefit you in the future to have an idea of these 15. Okay, you should be somewhere, you should at least be able to do it. Okay, when you do 7 times 7, you should get 49. 14 times 14, okay, that's not that hard. You could do it in your head if you want to or on the side. Obviously, use your calculator, but remember, there is a portion on the SAT that is non-calculator, and that's probably something that you would probably have to know or at least be able to work out to figure it out. Okay, because you can go off to the side and be like 14 times 14 and figure that out if you needed to. Okay, let's do perfect cubes, though. This one's a little bit harder. What's the first one?
1.
What about the second one? Okay, third? 4?
64.
5? Good. 6? Yeah, this is pretty tough. We're getting tough here, but yep, 343. 512. Yep. Beautiful. Okay, so really all you're doing is 1 cubed, 2 cubed, 3 cubed. Okay? 3 times 3 is 9, 9 times 3 is 27. That's how we're getting that. Okay, so when we do simplifying a radical, we have to, there's 2 ways to do it. Some people like to do the factor trees and break it all down, circle your groups, pull out. You know, if you have a friend, you can go outside the house and play. If you don't, you have to stay inside. Okay? Or you can just do the perfect square roots. I'm going to show you both ways, and you decide which one you like, because some people maybe really easy and really fast because you have those memorized. It might be faster for you to do the radical way. Or you can break it down into a tree. So we'll do the tree first to show you the longer way. But what two numbers go into 80? 10 and 8. Okay, can I reduce them even more?
Yeah.
10 breaks up into? And then 8 breaks up into? 2 and 4 breaks up into? Okay, now be careful. What I personally like to do if you do this method is the moment you draw a caret, that's what that's called, or you break it down, I tend to cross it out because they're gone. Okay, because a lot of people get confused when you break down radicals. So that's just my trick to you, is that the moment you break a number down, if you were to do this way, to cross off the moment you draw a caret so that you realize that that's no longer there. Because what we've seen is that people will circle them even though you've already broken them down. So now I have how many groups of 2 left over? Yeah, I have 2 groups, and what's left inside? 5. Very good. So if you like to do the circle, and the underline method, you can. Don't forget about this 2 all the way out here. So I have 2 times 2 times 2. And then don't forget about that square root of 5. And then I was told by Mike that it is 8, and you are correct. Now, I'm going to show you the other way. Because again, it just depends on who you are and how your brain works. Everyone is different. Okay? I personally like this way, but that's because I know my perfect square roots. If you don't, then it might be a little bit tougher. Okay, so what is, if you look at your list, is there any of these perfect squares that divide into 20? 4. So you could break this down into the square root of 4 and the square root of 5. Well, what is the square root of 4? And then you have root 5. Okay, so it just depends on who you are. If you can't see that right away, I recommend doing this. And sometimes you might be able to notice this pretty quickly, but there might be harder ones where you have to break the tree down. I even have to do it sometimes because I can't think of it. Okay, so I want you to do C. Give that a try. And again, it doesn't matter which method you use, you have to choose though. Sometimes you mix them up. I mix mine up. If you look at my key up here, there's one of them I broke it down to a tree because I didn't know right away. What is 29? What kind of number? Okay, walking around, looking around. You guys are doing pretty well with this. Come on. So again, there's 2 ways to do this. Who found the perfect square root that wasn't in it? Did anyone do the tree? You guys did nothing. Okay, so what did you guys do? Which one did you do for this one? Yeah, so the square root of 4 and the square root of 29. Well, we know the square root of 4, it is 2, and 29 is left over. Done. Okay, try D. Okay, that -3 is just hanging up on the outside of that house. That's okay. Take a minute and do number 3. If you have questions, now is a perfect time to ask. When you're done, and when you're done only, take a look up, please. You're doing it right. Well, 5 times 5 is 25. So it's 25 times 5. Yeah. How are you with those two? Are you okay? Okay, now these next ones are not exactly the same because we no longer have a square root. We have a cube root.
Wait, can you go back?
Yes, I can.
Is that a negative 3?
It is. Because of the -3 on the outside.
Okay.
Okay, so now let's take a look at the cube root. Now, when we did the tree method, we found groups of 2. Now, what are we going to find groups of? 3, okay? Or we're going to look at the perfect cubes and see which ones go in them, okay? Whatever method you like. Is there a perfect cube, when you look at your list, that goes into 81?
Yes.
Which one?
27.
Good. 27 and 3. So I have the cube root of 27 times the cube root of 3. Well, we know this one is ooh, that definitely was not supposed to happen. Okay, we know the cube root of 27. What is it?
3.
3. And then we just rewrite out this. Do you have questions on that? Okay, phones should be put away. Put them away. I'm going to bring my distraction box in here that I have to do with my other class. Where if you get one warning, and then the second warning you put in the box, you get the end of the hour. But if you like make a fuss out of it, then you get the end of the day. And then if you don't do it, you go to the deans with a referral. So don't maybe put that in here yet.
Can you do the next one?
It's working. Why? It's not worth it. Come on. Yes, let's do F as a factor tree just in case. Okay, because right away you might have just not realized it, and you like the factor tree, it's a lot easier, and you notice that there's a 0 at the end, and I could break that up into some kind of 10. So let's go ahead and do a factor tree just so that we can get used to that. I have 25 and 10. I'm only doing 10 because I know there's a 0 at the end, and that's probably the easiest way to go. Okay, but 25 breaks up into 5 and 5. 25 is gone because I broke it up. And then 10 is broken up into what? Good. 5 and 2, 10's gone. Now look, whenever I have a cube root, I now circle a group of 3, and the 2 is left over.
I thought you can only circle a
Pairs if it's a square root. Now we're in cube root. Does that make sense?
Whatever you're indexing will be how big of groups you want to make.
Yeah. So how would I write this? I want to hear you say it in words. See, it's not square root. What is it? I'm going to keep pushing you to say it correctly because remember, when we're doing this, I want you to understand when I say fifth root that you know what it means. Do you have questions on that? Okay, now let's do this one. Again, some of them are easier to see than others. Like this one, personally, I probably would have done it this way too because it's just faster. This one, though, is so small, you can probably find a perfect cube root. What's a perfect cube root that goes into 16?
8.
Very good, 8. So I have the cube root of 8 times the cube root of 2. So then I have what? Oh my God, you said it beautifully. Thank you. Okay, the more you say it, the more you understand. Flip the page when you're ready so I know you're good to go. No, because that's all review. This is going to be new now. That's review from last year. Here we go. We talked about this. Why would the square root of x squared have to have an absolute value of x as its answer?
Isn't it because the square root and the square cancel out, or no?
Yes, that is true. So you're left with x, but why do I have absolute value symbols here? One, what does absolute value mean?
It's gonna have an absolute minimum or maximum.
No, not necessarily. We're not talking about the graph. What'd you say back there?
Distance away from 0.
The distance away from 0, yes.
And what
Isn't
does
it only
distance?
positive?
What'd you say?
Range or
It's only positive?
It's only positive. Think absolute value is absolutely positive, okay? Absolute value is absolutely positive. It's only positive. So that's going to kind of help us out here. Only positive, just to make sure that you remember that. What? You can do that. That's fine. Those are your notes. But why? That's the big kicker here.
Barely be negative.
Why can't it be negative?
Oh wait, there can't be negative inside the radical.
Thank you. You can't have negative numbers inside the radical when you're talking about your radical function. Because remember, what'd you say? Outside's fine. You just can't have it in the inside. So let's look at our domain of this function. Last week we talked about what a radical function looked like on the graph. If you typed in the square root of x into your calculator right now, you would see that it looked like this. There are no negative numbers here. So I can't have negative inside, and that's because I can't have negative numbers in the radical. Okay? So that's why we have to have absolute values. Okay? Questions on that? Well, you gotta start taking notes. Here we go. Rewrite the radical by extracting all possible roots and then write the final answer in radical form. Use absolute values when necessary. So I highlighted that for a reason because I'm going to come up here and I'm going to put a little star because this is important. And a lot of people get this confused and get it wrong on the exam. If you have an even, I'm going to underline that because that's important, index. What does index mean? It's a little number inside the radical, right? Like the square root's 2, 3 is the cube root, okay? When you have an even index and an odd power result, you must have those absolute value signs. Okay, so for example, if I have square root, if I have fourth root or sixth root, automatically your brain should say, if I get a result with an odd power, I must put absolute value signs on it. If I have cube root, I'm good, because I didn't start with cube. Because cube, you can have anything in your domain. But radicals with the square or any kind of even, you can't have. So let's do some problems, for example, here. What technically is this index right here?
2.
Is it even?
Yes.
So do I have to make sure that I have absolute values at the end? It's not absolutely have to be absolute values, but what must I have then? What power, even or odd?
Odd.
Odd as a result. So let me rephrase that because I think my brain had a little stutter when I was doing that. Yes.
Like when you have an odd.
Odd index, you don't have to worry at all. Because remember the cube root graph looks like this, right? Because x cubed is this. The cube root of x is this way. See how forever goes left and forever goes right? Okay, whereas the radical stopped and it didn't have positive numbers. So we only have to worry about if we have an even index. So, but first, what is the square root of 16? 4. Okay, now let's talk about x to the 6th power. Does anyone know how many times I can take, or how many I can take out of my x to the 6th? 3. Why 3? Very good. So let me go over that. I'll stop here. You're asking yourself, I always kind of think of my index here too. How many times does 2 go into 6? 3. That's where I got 3 from. Okay, we don't have any left over because they were all taken. Now, I started with an even and I ended with an odd power. What must I have? Absolute value signs. That's a situation that you'd have to worry about. Only when there's an even index. Yes.
So it only goes over the x after 4.
Exactly. I mean, you could put it over the 4 because technically there is a 1 power, but. All right. Because what's the absolute value of 4? 4. That's kind of why we don't have to do that. Okay, what is my index here for B? 2. So do I have to at the end look to see if I need absolute? Yes, I do. Okay, but this one breaks down. We have the square root of 8. What do they break down into here? 4 and 2. So I'm going to go ahead and I'm going to bring that square root of 4, which is 2, outside. Now I ask myself, how many times does my index of 2 go into my power of 3 here? Only one time, right? So v to the first power. But how many now is left over? 1. Very good. So the square root of v. Where must my absolute value sign go?
Would it be square root 2?
Yeah, see? That's why I have you. You know, I need you guys to support me just as much as I support you. Good question. Here, if you want to just kind of know why this is, if you want to go off to the side, really this means v times v times v. Well, I have one group that comes out and one stays. If that helps you. But there's going to be situations like, what if I gave you x to the 100? That would take forever to do some circling.
Where did the negative
The negative's from here. The 2's from here. So if you need to draw an arrow, that's where they came from. Question, yes?
I'm getting the habit of doing the same thing with the variables, like the v.
Yes. I'm missing something. What am I missing? Absolute values. Where? On what? Because I have one group of v that comes out. Okay? Yep. It's okay. We're going to keep trying it. Moving on. What's my index? 2. How many? So this is one group. If you look at it, it's in a parentheses. How many groups of x plus 3 can I pull out? How many can I pull out? 1. So I have x plus 3 to the first power. Am I done?
No, you gotta put an absolute value.
I do. Around what? This is the trick. The whole thing. Thank you. Here's why. Here's why. Technically, you have x plus 3 all the first power, because that's what you pulled out. So the whole thing needs to be in absolute values. Okay? You're always asking yourself, when you're doing these problems, how many times does my index go into a power? It went in once. Really, that means 2 divided by 2 is 1. Yes?
So we could pull that out because it was square.
Yes. So technically, just to visualize, you have x plus 3 times x plus 3, which is a group that you would pull out if you do it that way. Yes. Okay. I want you to try D. Look at your index, identify what it is, and then walk yourself through it or with your group. Take it piece by piece, each one. Every color is a different part. Okay, so now I'm going to walk you through it to make sure that you understood it. And if you weren't getting it, now is a very good time to focus because I'm going to break each one down. 63 can be broken down into the square root of 9 and the square root of what? 7. Okay? So, what I like to do to prepare for this is to just draw my square root symbol, just getting ready, because some stay inside, some go on the outside. But what is what is the square root of 9? Where does a 7 go, on the inside or the outside? So, inside. Okay, we're done with the blue part. Let's move on, the yellow part, let's move on to the green. How many times does my index of 2 go into my power of 4? 2 times. So I have h squared. Is there anything left? No, because technically h squared times h squared is h to the 4th, which is what we started with. Okay? So now how many times does my index of 2 go into my power of 6? 3. Do I have anything left over? No. Final step. Absolute value around what one? Just j. It has to be odd power. You're done. even index, odd power result. Okay? It takes time and practice. Let's do another one here. Actually, no, try E one more time. Maybe that one kind of explained it for you. Take 1 minute and see how you do. You can't have All right, I'm going to go over it. Pick it up a little bit here. The square root of 25 was pretty straightforward. Beautiful. Okay, now let's talk about this. Here's where people get a little stuck. There is an index of 2. I won't explain this again. How many times does 2 go into the power of 2? 1 time. Is there anything left over? No. So I just put A. Now, how many times does 2 go into 8? 4. So I have B to the 4th. Okay, because 4 times 2 is 8, and that's why it goes here. How many times does 2 go into C to the 10th? Oh, I just gave you the answer. 5 times. Is there anything left over? No, so I don't even need this radical anymore. However, I'm missing something. The absolute values. Okay? You could write it like that, or you could have wrote it like this. 5A to the B, sorry, C to the 5th. You could have wrote it like this, and then B to the 4th. It really doesn't matter. You could have left it with the 2 absolutes, or you can like put it into 1. It doesn't matter. I feel like if you were taking the SAT, like it would look like this. It would not look like that. Okay, so make sure you're able to establish that. We're almost done. Bueller. Anyone? Am I really that old? Ferris Bueller's Day Off. Thank you. Now, here's what I need to ask you, because this is an important question. I have a cube root. Do I have to worry about absolutes anymore? No, only when I have an even index, because again, my domain now goes forever left and forever right. So, break this down, or do you know the perfect cube of 343? 7. Yeah, so I have 7 on the outside. I'm going to prepare this over here to the right side. Here we go. How many times does 3 go into 15? 5. So I have A to the 5th. How many times does 3 go into 10? 3 times. With 1 left over. Very good. I don't need absolute values because I have an odd to start off with. Think. 3 times 3 is 9, but I need 10. That's why there's 1 left over. Okay? This one. Pretty straightforward. Can anyone just tell me what it is right away? Good. But that's that it? Absolute, because I started with an even index. That's why we have to worry about the absolute values. Last and final one here. I always ask myself, what's the index? Do I need absolute values? No. How many times does 3 go into 9? 3 times. So I have x plus 3 all cubed. Okay? Again, I'm not saying this is easy, but you can do it. You need to keep practicing. Maybe watch the video one more time if you need to. Your homework should be coming. You still have a lot of people had the same amount of time first hour and they finished because it's pretty fast.